this video, we're going to be mixing in a little bit of review about exponents along with negative exponents. You know negative exponents, those ones always have the bad attitude. But seriously, most of these rules will be intuitive. There's going to be a lot of mixtures of combinations of powers and products, products of powers, powers of products, and all that stuff. Don't get too caught up in the wording. Get caught up in the process. Follow the patterns. Let's get moving. First, this idea of recognizing patterns without a calculator. Okay, so let's gravitate over to the 2 tables, right? So 2 to the first, right? That's pretty straightforward. That's just 2. And 2 squared is 2 times 2 is 4. And 2 to the third is 2 times itself 3 times, or 4 times 2. 8 times 2 would be another multiple. 16 times 2 is 32. As you look down, right, I guess we're looking at a pattern of dividing by 2. So as I go from 32 to 16, I divide by 2. 16 to 8, I divide by 2, divide by 2, divide by 2. Now we already know that 2 to the 0 is 1. And 2 divided by 2 is 1. What is 1 divided by 2? 1/2. What's 1/2 divided by 2? Well, 1/2 divided by 2 is 1/2 times 1 over 2, right? We multiply by the reciprocal, which is going to be 1/4. So now I got 1/4. And then if I multiply that by 1/2, I'm going to get 1/8. And you can see from up at the top that these numbers are all showing up in the denominator at this point. So I guess 2 to the negative fourth is 1 over 16, and 2 to the negative fifth is 1 over 32. Now let's just process the same thing for the 3 tables. Press pause and complete the 3 tables on your own. So again, 3 to the first is just itself, and 3 to the 0 is 1. 3 squared is 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. 81 times 3 is 243. If we take these and sort of go in the reverse pattern of dividing by 3 as we go down, 3 divided by 3 is 1. Divided by 3 is 1/3. Divided by 3, or multiplied by 1/3, is 1/9. By 1/3 is multiplied by 1/3, or divided by 3 is 1/27, 1/81st, and 1 over 243. Okay, these will be helpful, just like knowing your exponents for 2 through 10 was good to know, right? So knowing at least all the perfect squares through 20 is helpful. Knowing some of these patterns is also helpful. It's all about efficiency and fluency. So let's take what we just learned and sort of apply a rule to it. So 3 squared is 9, and 3 to the negative 2 is 1 over 9. Then I guess x to the negative n is the same as saying 1 over x to the positive n. And if this is over 1, then wouldn't that mean that x to the negative n in the denominator would be x to the positive n in the numerator, right? So think about that as just flipping those over. Again, you want to see it without the crutch. So x to the negative third would be 1 over x to the positive third. And 1 over x to the fourth is just going to be x to the fourth, right? If it's in the numerator, I'm going to move it to the denominator and make it positive. If the negative exponent is in the denominator, I'm going to shift that to the numerator and change the sign. Okay, so how about 2x to the negative third? We're going to say that that's 1 over 2x to the positive third. And then 2x to the negative third. Notice over here, there is no parentheses around the 2x. So the 2 is going to stay where it is. It's only the x that has the negative exponent applied to it. Okay, so again, notice this whole thing went to the denominator because the whole parenthetical expression was raised to that negative third power. And then, of course, the power of 0 is 1. All right. That covers our properties of negative exponents and power of 0. Let's move on to some more properties. You know, I'm thinking with all these properties that math has, math should have been a landlord. Ba-dum-bum. Okay, product of powers. Let's move on. I'll save my comedy career for post-education. If you had x to the third times x to the fourth, you already know that to be x to the seventh, right? What did we do with these exponents? We added them. So in general, x to the m times x to the n is going to be x to the m plus n, right? That's qualifies under the review piece. So now we're just introducing this new idea that, well, if we have -6 and 4, that's going to be x to the -2. And now we know that we don't want to leave a negative exponent, so that's going to be 1 over x squared. Alrighty. And then we have 5 to the -3rd and 5 to the -2nd, right? So that's going to be 5 to the -5th, or 1 over 5 to the 5th. And then we just want to evaluate what 5 to the 5th is. So we grab a little technical assistance, and we're going to say that that's 1 over 3,125. If you try to just pump that whole thing into a calculator, you're going to get 3.2 e to the -4, which means it's 1, 2, 3, 4 hops over here, so 3 zeros, and you got 3, 2, which is a rough description of what the 1 divided by 3,125 is in decimal form. So that's not going to work out. You're going to need to know the process and maybe just a little bit of help when you need the big number evaluated for you. Essentially, tough to cheat. The other thing too is you could hit math enter and turn that back into a fraction. It would bring you back to this answer, but the problem is it's not going to help you with this. So you really do need to understand the rule. Now we're going to work on power of a power. All right. So here we have x to the m raised to the n. We are going to multiply when we raise a power to a power. So that's m times n. And the biggest thing to get this confused with is x to the m times x to the n is x to the m plus n. So when we multiply of the same base, we add the exponents. Versus when we raise a power to a power, hence power to a power, we will multiply. So down here, this is going to be x to the -18th, because -6 times 3 is -18. But then we don't want to leave the negative exponent. That's going to be 1 over x to the +18th. Down at the bottom, this is going to be m to the, notice there's a negative times a negative, +10th, and that's it. Now we're going to move on to power of a product. So inside the parentheses, we have a product of x times y raised to a power of n. And in general, that is going to be basically applying that power to each variable in the product. So xy raised to the n would be raising x to the n, then raising y to the n. So we'll approach this slowly. So first, 4 squared, x to the -3, raised to the second power. I'm going to multiply. That's going to be a -6. And then y to the first raised to the second is y squared. Okay, now let's keep cleaning this up. I can evaluate the 4 squared to be 16. X to the -6 is in the numerator. It's going to go down to the denominator, become positive. And y squared stays up at the top. There's our final answer. Okay, for our last problem here, we're going to have 9 raised to the -1st. So that's 9 to the -1. M is raised to the -4th already. So -4 times the -1 is going to be m to the +4th. And then n squared, 2 times -1 is -2. So now we'll just square away our positive negatives. 9 to the -1st comes down to be 9 to the +1st, or just 9. M to the 4th stays where it is. N to the -2 comes down to the bottom and becomes positive. And that's that. Now let's just say, for instance, that we had an answer where there was nothing left at the top, and it was just like x to the 4th, y squared. And those were the only two variables. I guess the prior step was x to the -4, y -2. So it went to this. You should leave a 1 up top as a placeholder if there's nothing else up there. So if you want, you can put a 1 down in the bottom here. It's totally optional. It's assumed to be a 1 m to the 4th. So just a reminder that if multiplication implies addition, then division probably implies subtraction. Now, of course, this is assuming that we're dealing with the same base. So this is the same value, x and x is going to be m to the minus n, right? So x to the m minus n. So we come over to the example. This is both n and n, so we can say this is n to the 18, the numerator, minus the denominator. So 18 minus the negative 2 is 18 plus 2, so that's n to the 20th. Now, just for the record, that would work with numbers too. So say it was like 7 to the 3rd over 7 to the 5th. That would be 7 to the 3 minus 5, which would be 7 to the negative 2, which would be 1 over 7 squared, which is 49. Right? You could evaluate this, make this a really big number, make this a really big number, and then do the division. Or you could look at it as sort of like 3 7s on the top and 5 on the bottom. 3 cancels, that's 1 over 49. So there's lots of ways to look at these rules and to negotiate in your head that they do work. Last one, m to the negative 13, the numerator minus the denominator. So it's going to be negative 13 plus 5. So that's m to the negative 8. Can't leave the negative in the numerator. We're going to shift that down. All set. 1 over m to the 8th. And just as we had the power of the product, we're going to have the power of the quotient. Essentially the same gig, you know. Again, intuition tells me that I'm just going to apply the power to both the numerator and the denominator in the quotient. And then simplify anything if there is anything. So in the second example, well, up at the top of the numerator, we have the power of the product. So 7, right, this is going to be 7 squared. X to the negative 5 times 2, which is negative 10, okay, all over 3 squared. So that's going to be 49 over 9, and then x to the negative 10 is going to come down to the bottom to become x over 10. Last thing we want to know is there any kind of reduction to be done there? That is, could you simplify 49 over 9? So 49, the only multiples of 49 are 7 and 7, right? And then 1 and 49. For 9, it's 1, 3, and 9. None of those overlap, so no, you can't simplify that. That is our final answer. Last problem. We have 2 to the raised to the negative 3rd power. We have m raised to the negative 3rd power. We have n to the negative 6 raised to the negative 3rd, so we're going to multiply those two values. Negative 6 times negative 3 is positive 18 all over. 5 to the negative 3rd power, and then x to the 3rd raised to the negative 3rd, so we're going to multiply and get x to the negative 9. Now we're going to clean some of this up. So 2 to the negative 3rd is going to come down to the bottom. Let me 2 to the 3rd. 5 to the negative 3rd is going to go to the top. 5 to the positive 3rd. M to the negative 3rd is going to come down to the bottom, become positive. X to the negative 9th is going to go to the top to become positive. And n to the 18th stays up there. The last thing we're going to do is we're just going to evaluate 5 to the 3rd, which is 125. 2 to the 3rd can be evaluated to be 8. And 125 over 8 can't be reduced, so I'm just going to leave it as 125 over 8. And all the variables stay. x9, n to the 18th, m to the 3rd. Sorry for squeezing all that in there, but that is our final answer. Now again, off on the side, say I moved a bunch of things around and I had like x to the negative 3 and then m to the negative 7th and then x to the 10th up here. I would bump the m to the 7th down, I'd bump the x to the negative 3 up, and then I have this x to the 10th up here. Oh, I would make that x to the 13th because I'd add them. Or if I ended up moving, you know, x to the negative 7th and then I had x to the negative 4th, a lot of students say, you know, well, what do you do about that? You know, how do you handle that? For me, personal opinion, one of the things you can do is you could just do x to the negative 7 minus the negative 4, which is going to be x to the negative 3, which is 1 over x to the 3rd, right? You could leave that as the final answer, right? Or you could be that person who wants to get rid of the negatives first. So you could say, well, this is going to be x to the 4th up at the top, and this is going to be x to the 7th at the bottom. And then do x to the 4 minus 7, which is x to the negative 3rd which is 1 over x to the third. So either way, you're going to end up with 1 over x to the third. The point of it is to take little bite-sized steps, right? So take a bite-sized step, deal with this first, right? Get that -3 applied to all of the values inside. Then I like to get rid of the negatives. The less the negatives on the screen, the easier it is for me to deal with. And then at the end, look for anything that you can combine, simplify, reduce, yada, yada, yada. So that about wraps us up for exponent review and negative exponents mixed in. Feel free to get a hold of us if you need any help. Good luck.